Since computers run on electricity, we can understand computers much better if we understand the basics of electricity. So let's look at an overview of what we're going to cover. First, we're going to talk about what electricity is and how it's measured. Then we'll talk about AC current versus DC current. Then we'll discuss the basics of electronic components. And finally, we'll look at some devices that are used to protect a computer from power spikes and sags. So basically, electricity is a transfer of energy, and we can't see electricity, but we can see water. So if we were to look at water, the low pressure would be just water in a lake or in a river. If we pump that water up and then let it drop across a water wheel, it would create energy. The gravity would pull the water across the water wheel. That's how we create hydroelectric current. Then the water falls back into the lake or the river, and there's a low pressure system. The same thing happens with a battery and a light bulb in this example of electricity. Although we can't see it, it's a transfer of energy. And as the energy, the high pressure energy, goes across the filament of the light bulb, it causes that filament to glow, which then burns the energy or transfers the energy into the filament, and then the battery recharges the system and it all happens again. So although we can't see electricity, if we compare it with something that we can see, we can kind of understand the flow of the electrons. And basically, it's all just a transfer of energy. We measure electricity with the following properties: voltage, amperage, ohms, and wattage. Let's look at voltage first. Voltage is electrical pressure that causes current to flow. If you compared that to water, electrical pressure is like the water pressure in your house. That's what causes the water to flow. So voltage is the electrical pressure that causes the current to flow inside of the wires or inside of the circuits. The current that is created is called amperage. An ampere is a unit of measurement for electrical current. 1 volt across a resistance of 1 ohm, which we'll cover in just a second, will produce the flow of 1 amp. So 1 volt across the resistance of 1 ohm produces 1 amp. The pressure that causes the current to flow is voltage. The current, the speed of the current, is referred to as amperage. When current flows through a substance, though, there's some resistance. We measure resistance in ohms. So an ohm is the standard unit of measurement for electrical resistance, and resistors are rated in ohms. Resistors are devices in electrical circuits that resist the flow of electricity, and we can control the flow of electricity in a circuit using resistors. When we talk about power, what we're actually talking about is wattage, because wattage is the total amount of power needed to operate an electrical device. It's measured in what we call watts, and watts equal volts times amps. So when we talk about a 100-watt light bulb, that's what we're talking about, is that in order to light that light bulb as it should be, we're going to be using 100 watts of electricity, or we're going to be using 100 watts of power. But voltage times amperage equals wattage. There are 2 types of electrical current, and we'll discuss the 2 types of electrical current and the similarities and differences between them next.